Okay students, so moving on to the next section which contains multiple correct type questions. We have question number 50 which says that the equation sin square x minus 2 sin x plus a square equals 0 possesses a solution for all values of a belonging to the interval. Students, we can directly write that a square is equal to 2 sin x minus sin square x, and we can easily say that if sin x is t, this is 2t minus t square or t into 2 minus t, and that is a quadratic equation in t. Here sin x is t, and since sin x belongs from minus 1 to 1, we have to draw the graph only from minus 1 to 1. So let us go for it. This graph has roots t equal to 0 and t equal to 2. Obviously sin x can never be 2. Minus 1 to 1. What is the value of at minus 1 and what is the value at 1? Let us see. At minus 1, this is minus 1 into 3. So this value is minus 3. At 1, the value is 1 into 1. So it is 1. Students, on the left hand side, I have a square. Okay. The range of t into 2 minus t, where t belongs to minus 1 to 1, is minus 3 to 1. But on the contrary, we have a square in the left hand side. So a square is a non-negative number. So clearly a square and this particular range have a common interval of 0 to 1. That means mod a is less than equal to 1 is the solution. A belongs to minus 1 to 1. This is the final answer. Option number A is correct, B is correct, C is correct, D is correct. All 4 options are correct. You just have to compare the range. It is a very simple question. Okay, let us move on to 51. Question number 51 says that the number of points of intersection of the graphs of y equal to cos of tan x cos x and y equals to sin of cot x sin x is. Students, y is first one. Let us say y1 cos of tan x into cos x. So tan x is sin x upon cos x. So cos of sin x. And y2 is equal to sin of cot x is cos x upon sin x into sin x is cos x. There is a very simple fundamental in order to prove that these two graphs never ever have a point of intersection. Let us focus on that fundamental. We know that sin x plus cos x is less than equal to root 2. In the other words, I can say sin x plus cos x is less than pi by 2. Okay? So which means that cos x is less than pi by 2 minus sin x. Students, if we apply sine on both the sides, I will have sine of cos x less than sine of pi by 2 minus sin x. That means cos of sin x. And students, this is an inequality which is true for all x belongs to R. Okay. So ultimately I have y2 less than y1. So there is no chance that y1 is equal to y2 ever in x belongs to R. So whatever is the interval given, the number of points of intersection of these two graphs are 0 always. So A and C are the correct options for question number 51. Let us move on to 52. Question number 52 says that if L is equal to limit x tends to 0, sin 2x minus a cos x plus bx into log of 1 plus x whole divided by x square minus cx square plus dx plus e whole divided by x cube exists and is finite, then. Students, in this type of questions, what do we have to do? We have to take the LCM of all the terms and then we have to apply series expansion. Okay. So L is a value which is limit x tends to 0. Let us take the LCM straight away. X sin 2x minus ax cos x plus bx square log of 1 plus x minus cx square minus dx minus e whole divided by x cube. So for cos x, for sin 2x, for log of 1 plus x, let us use expansions. L is limit x tends to 0, 1 upon x cube whole multiplied by x into, the expansion of sin x is x minus x cube by 3 factorial plus x power 5 upon 5 factorial. I need the terms up to x cube only, so I'll write 2x minus 2x whole cube by 3 factorial plus so on till up to infinity. So the rest terms are not required anyhow. Minus ax. Cos x is 1 minus x square by 2 factorial. X power 4 terms are not required. So let it be. Plus bx square into log of 1 plus x, which is x minus x square by 2. And the further terms are not required. Minus cx square minus dx minus c. So let us collect the coefficients carefully. Limit x tends to 0. The constant term appears to be minus e. The coefficient of x appears to be minus a from here and minus d from here. Minus a minus d into x. The coefficient of x square will be 2x square from this term and minus cx square. So 2 minus c times x square. The coefficient of x cube. I'm only concerned till x cube. Okay, because denominator has degree 3. The coefficient of x cube will be, from the first term there is no coefficient. From the second term it is a by 2. From the third term it is b. X cube. Plus x power 4 and x power 5 higher terms will come. I'm not concerned about them because they will tend to 0 because limit x is tending to 0. अगर यहाँ पे L को finitely exist करना है तो न्यूमिनेटर में constant term x और x square के coefficient को होना पड़ेगा 0. यानी कि e की वैल्यू आएगी 0, a plus d की वैल्यू आएगी 0 और c की वैल्यू आएगी 2. x क्यूब का कोएफिशिएंट जो न्यूमिनेटर में है वही हमारी L का आंसर है. That is a by 2 plus b. A by 2 plus b. This is the answer for the question L. C is 2 correct. P is 0 correct. L is a plus 2b by 2 correct. A plus c plus d plus e. A plus d plus e is 0. C is 2. So correct. All the 4 options are correct for this particular question. A, B, C, D is the final answer. Okay. Let us move on to question number 53. Question 53 says that consider 3 complex numbers z1, z2, z3 such that their modulus is equal to 1. All 3 moduli are equal. S is expression mod of z2 minus z3 whole square plus mod of z1 minus z2 whole square plus mod of z3 minus z1 whole square. And alpha is the minimum value of S, beta is the maximum value of S. Students, we can clearly see that S is the distance between z2 minus z3 whole square plus the distance between z1 minus z2 whole square plus distance between z3 minus z1 whole square. So the minimum value of S will be obtained when z1, z2, z3 are the same complex numbers and they can lie on the unit circle anywhere, but they have to be same. So the alpha, which is the minimum value, will be 0 plus 0 plus 0, and that is 0. Further, beta, the maximum value, distance means separation. Z1, Z2, Z3, S contains the cyclic factors of the distances between these 3 points. That means beta, the maximum value of S, will occur only when Z1, Z2, Z3 are equally separated, and they are separated when, for a particular case, can be taken out to be equal to 1 omega omega square, which are the cube roots of unity because they are already lying on the unit circle. So if we have these 3 points, then this distance is root 3 whole square plus root 3 whole square plus root 3 whole square. You can easily calculate the moduli. So this is 3 plus 3 plus 3. The value of beta comes out to be equal to 9. So we have alpha 0, beta 9. Answer is option number A and option number B. Okay. Let us move forward to question number 54. Question number 54 says that if x is greater than 0 and g is a bounded function, then what is the value of limit n tends to infinity fx into e power nx plus gx whole divided by e power nx plus 1. Students, gx is a bounded function. That means if gx is divided by a quantity which is approaching infinity, that particular value will tend to 0 directly. Okay, that is the meaning. So in order to evaluate this limit, we'll have to take e power nx multiplied by fx plus gx upon e power nx, which I told you that it will be 0 when n tends to infinity, whole divided by e power nx into 1 plus 1 upon e power nx. Students, very carefully, we can easily cancel the term, this one. We also know that this term tends to 0 because gx is given to be a bounded function, and definitely this term also tends to 0 when n tends to infinity. Okay, so the answer of this question within a single step is simply fx, which means option number B is correct. Okay, only one option is correct out of this question. Let us move on to 55. Question number 55 says that let n be a number which is given as 2 power 40, 3 power 5, 5 power 3, and p denotes the product of those divisors of n which leaves remainder 1 when divided by 4. Then p is divisible by. I need the divisors which are of the form 4n plus 1 because they leave remainder 1 when divided by 4. What is meant by the question? Okay, n value is 2 power 40, 3 power 5, 5 power 3. अगर हमें 4n plus 1 टाइप का डिविजर चाहिए तो हमें ये क्लियर होना चाहिए कि 2 की कोई भी पावर नहीं आ सकती. ठीक है, 4n plus 1 टाइप के जो सारे डिविजर्स होंगे वो 3 और 5 के कॉम्बिनेशन से मिलेंगे. And the combinations can be obtained by multiplying any two terms of these two brackets. Let me show you. 3 power 0, 3 power 2 and 3 power 4. 3 power 1 and 3 power 3 are not included because 3 power 1 is 3 is 27. They are not of the form 4n plus 1. Multiplied by 5 power 0, 5 power 1, 5 power 2, 5 power 3. So that means there are 12 terms, 3 multiplied by 4. So that means there are 12 divisors of this number n which are of the form 4n plus 1. Let us quickly write them down. 3 power 0, 5 power 0 which means 1. 3 power 0, 5 power 1 which means 5. 3 power 0, 5 power 2, 25. 3 power 0, 5 power 3, 125. 3 square 5 power 0, 9. 3 square 5 power 1, 45. 3 square 5 square 225. 3 square 5 cube and so on for 3 power 4. 3 power 4 5 power 0. 3 power 4 5 power 1. 3 power 4 5 power 2 and 3 power 4 5 power 3. I need the product of all these terms. P is the product. Let us do one by one. 3 power 16 5 power 6. This is 3 power 8 5 power 6 and this is 3 power 0 5 power 6. Ultimately the product is 3 raised to the power 0 plus 8 plus 16, so 3 raised to the power 24 multiplied by 5 raised to the power 6 plus 6 plus 6, 5 power 18. Now the question says that this product is divisible by 15 raised to the power 18 multiplied by 3 raised to the power 6. This is the another way to write the same thing. A option is correct. B option is not correct because it is 15 power 20. C option is 3 power 20. Very true from the first part. D option is 15 power 18. Yes. So final answer for this question is ACD. Okay. With this, we are done with this section. Let us move on to match the column type questions.